All right, let's get right into it. Look, if you're tuning in, it means you are completely serious about getting your aviation maintenance certification. I'm your instructor, and today we are walking through a high-yield exam review explainer on aviation maintenance documentation. We aren't just memorizing boring manuals here. We are learning the actual language of aviation safety. This masterclass is designed to give you exactly what you need to know, clear out all the extra noise, and get you absolutely bulletproof for the exam. Okay, let's dive into this. Here is the syllabus for today's masterclass. This structure right here is exactly how you need to organize your brain for the certification exam. We're going to hit the cradle-to-grave lifecycle, the 4 main documentation types, decoding the ATA 100 system, master maintenance page blocks, and we'll wrap it up with the aircraft structure zoning system. All right, kicking things off with Section 1, the cradle-to-grave lifecycle. I really need you to pay close attention here, guys, because this is foundational to everything else we're going to talk about. So, cradle to the grave. This phrase is a highly testable definition. It means that the documentation for an aircraft starts the absolute second it's built. From that exact moment throughout its entire service life, every single maintenance action, every inspection, every modification is recorded. This continuous, unbroken chain of records is gathered until the aircraft is finally decommissioned. It's a massive thematic anchor for this whole explainer. It's literally the entire history of the airframe, unbroken. Now, you might be wondering, why do we go through all this trouble to keep these records? Well, simply put, because the FAA says so. Specifically, FAA Advisory Circular AC 120-16F. You absolutely must memorize the 2 main systems mandated here. First, the Air Carrier Maintenance Manual System, and second, the Documentation Keeping System. This advisory circular is the regulatory backbone that actually forces that cradle-to-grave life cycle we just talked about to happen. Memorize both of those systems for test day. Moving right along to Section 2, the 4 main documentation types. Grab your pens, because this is pure, high-yield memorization material. Seriously, if you take absolutely nothing else away from today, remember this exact list. The 4 main types of documentation you will use in aviation maintenance are, number 1, manufacturer's documentation, number 2, regulatory documentation, number 3, airline-generated documentation, and number 4, ATA document standards. Go ahead and burn those 4 into your memory right now. Now, what's really interesting about this is the sharp contrast between the first and third types on that list. Manufacturer's documentation is super generic. It's produced by the builder, it applies to every aircraft of that type, and it operates on standard, very predictable revision cycles. But airline-generated documentation, that is highly customized for a specific operator based strictly on their own FAA-approved operations. It has incredibly limited distribution purely within that one airline and has its own internal revision schedule. Knowing the difference between the generic builder manual and the customized airline manual is a total must. All right, Section 3, decoding the ATA 100 system. Honestly, this is where things get really fun. We are not just looking at boring numbers here. This is a universal code every single mechanic has to crack. Imagine you're out there on the flight line, the clock is ticking, and you need to replace one specific passenger door handle. How in the world do you find the instructions for that single door handle in a maintenance manual that might be 10,000 pages long? You obviously can't just flip through it and hope to get lucky. You need a rock-solid system. And that system is the ATA 100 system. The Air Transport Association literally standardized the overall format of all maintenance manuals. It's a real game changer because it means whether you are looking at a Boeing, an Airbus, or a Cessna manual, the basic categorization is exactly the same. It drastically reduces confusion on the flight line by forcing a universal standard. So let's crack this code together, step by step. Look at the number of 521102 It stacks logically like a giant puzzle. The first 2 digits, 52, represent the ATA chapter, which is universally doors. The next 2 digits, 11, narrow down the subject to passenger doors. The third set, 02, pinpoints the section, which is the specific passenger door handle. And that final 3-digit block, 401, is the page block. That tells us the exact procedure, in this case, removal and installation. See how that works? To navigate this quickly on the floor, you really need to memorize these broad groupings. Chapters 00 to 18 are your aircraft general. 20 to 50 cover the systems, think hydraulics and electrical. 51 to 57 are aircraft structures. 60 to 67 deal with propellers and rotors. And 70 to 100 cover the power plant, the engines. Memorizing these blocks is absolutely crucial so you can instantly zero in on a system during your exam without second-guessing yourself. Okay, moving to Section 4, Master Maintenance Page Blocks. I'm telling you right now, this section is exam gold. And this brilliantly illustrates why that standard format works so well. While the middle subject numbers might vary a bit, that last group of 3 digits, the page block, is identical across all maintenance manuals. I highly recommend you study and memorize the exact action associated with these 100 number blocks. If it ends between 001 and 099, you are looking at description and operation. 101 to 199 is fault isolation, basically troubleshooting. 201 to 299 covers maintenance practices, and 301 to 399 is servicing, checking fluids and that sort of thing. Let's continue with the rest of the blocks. I literally cannot stress this enough. You have to know these. Block 401 to 499 is specifically for removal and installation, like taking out a line replaceable unit, an LRU, and putting a new one in. 501 to 599 is adjustment and test. Block 601 to 699 is for inspections and checks, specifically those zonal inspections. 701 to 799 is cleaning and painting, and 801 to 899 covers FAA-approved repairs. Look, just make sure you know what Block 401 and Block 601 mean, period. All right, home stretch, Section 5, the Aircraft Structure Zoning System. We're moving off the paper manuals and onto the actual physical geography of the aircraft itself. Let's keep the energy up. So, for large commercial aircraft, zoning is specified by the ATA 100 spec. You need to know these major zones. Zone 100 is the lower fuselage, 200 is the upper fuselage, 300 is the empennage or the tail section, 400 is the power plants. Now check out the logical flow here. 500 is the left wing, and 600 is the right wing. 700 covers the landing gear, and 800 is all about doors. It's just a highly systematic mapping of the entire large airframe. Now, we have to contrast that massive commercial jet zoning with how we handle smaller planes. For small, light aircraft, broad zones are way too clunky. They just aren't accurate enough. Instead, manufacturers use a super precise numbering system of localized stations to pinpoint exactly where a component is located. But to get that pinpoint accuracy, you need a starting point. Enter the reference datum. It is an imaginary vertical plane at or near the nose of the aircraft. From this datum, all fore and aft distances are measured in inches. Let me be clear, this is a non-negotiable definition. The reference datum is the absolute 0 point for every single longitudinal measurement on that airframe. So the crucial point here is how we actually use that datum. We measure specific locations using stations. A fuselage station, or FS, is measured in inches straight back from the reference datum. We also use butt line for left and right measurements from the center, water line for vertical measurements, wing stations measured outboard from the wing root, and even specific aileron or nacelle stations. The key takeaway is they are all incredibly precise measurements from a known reference point. Okay, let's tie this whole cradle-to-grave journey together with a quick pop quiz scenario. If you're assigned to do a 400-block procedure on ATA Chapter 52 in Major Zone 800, what exactly are you doing and where are you doing it? Think about it for a second. Chapter 52, that means doors. Zone 800, that means you are physically located at the doors. And a 400-block procedure, that means removal and installation. So you are out there removing and installing a door component. If you can decode a sentence like that, you are well on your way to absolutely acing this exam. Keep studying, review these concepts, and I'll see you out on the flight line.